Today we're going to be talking about and introducing the law of sines and the law of cosines. We're going to be talking about oblique triangles. Those are triangles that are not right triangles. So the first thing we can talk about is the law of sines. Law of sines says this: if you have some triangle ABC and side lengths across from angles A, B, and C, then the sine of A over the side of A is equal to the sine of B over side B equal to the sine of C over side C. So we can use that to find angles and or side lengths. So if I look at this one right here, it says solve triangle ABC, round side lengths to the nearest tenth and angle measures to the nearest degree. Okay, so first we can say, all right, well, I know that this is 35 degrees and it's across from side A. So I can say sine of 35 degrees over A is equal to, now I know angle B is 103 and it's across from side 20, sine of 103 over side 20. And the last one, side C, I can do it one of two ways. One, I know that all triangles add up to 180 degrees, so I can take 103 plus 35, which is 138, and subtract 180 from it, and so that would be 42. So sine of 42 degrees over C. So now I can use this information to solve for both side A and side C. So let's look at this part first, okay? Figure out what A is. So this is just written just like a proportion. To solve, we cross multiply. So we get A sine of 103 degrees is equal to 20 sine 35 degrees. If I want A by myself right here, I would divide both sides by the sine of 103. And so A is going to equal 11.8 approximately. I did that by just putting that into my calculator. Now, let's look at this one. Sine of 103 over 20 is equal to the sine of 42 over C. Cross multiply the same as I did before. So C sine of 103 is equal to 20 sine of 42. Divide by sine of 103. Divide by sine of 103. And I find that C is the value approximately 13.7. Okay, so we can just use the law of sines to find the missing sides of our oblique triangle. Here's some other examples if you'd like to try some on your own. Now what we can do is we can apply our law of sines to a word problem. It says an Earth orbiting satellite is passing between Oak Ridge Laboratory in Tennessee and the Langley Research Center in Virginia, which are 446 miles apart. If the angles of elevation to the satellite from the Oak Ridge and Langley facilities are 58 degrees and 72 degrees respectively, which means in that order, how far is the satellite from each station? Okay, so essentially we have 58 degrees, 72 degrees, and we can find what that last angle is right there, angle C, by taking 180 minus 72 minus 58. Which is 50 degrees. So angle C right here is 50 degrees. Okay? So now I can set up my law of sines. Okay, so I'll say sine of 58 degrees over A, which I don't know, is the same as the sine of 50 degrees over 446 miles. Okay, solve it, cross multiply. So I'd get A sine of 50 is equal to 446 sine of 58. Divide both sides by sine of 50. And I find that A is going to be the measurement 493.7 miles. Okay? I'll do the exact same thing to find B. I'll say sine of 72 degrees over B is equal to sine of 50 degrees all over 446. Again, cross multiply. And I get B sine of 50 is equal to 446 sine of 72. Divide by sine 50. Divide by sine 50. And I get B is equal to 553.7 miles. Okay? So this would be 553.7 miles. Here's another example right here that has to do with shipping yards and shipping traveling from port. You can try the exact same right now. There's also times when we have what are called ambiguous cases, and this would be when there's no solution, one solution, or two solutions based on the different triangles that you might have. Okay, so here they are. They're in your notes. You can look at them. You can look them over real quick. All right, so it says find all solutions for the given triangle if possible. If no solution exists, write no solution. Round side lengths to the nearest tenth and angle measures to the nearest degree. So here's our triangle right here. We know that angle A is 94 degrees. We know that that's across from side 15. Okay, so we could say sine of 94 over 15 is equal to, and I can use that to find angle C real quick. So that would be sine of C over 12. Okay, we cross multiply, and we'd say 12 sine of 94 is equal to 15 sine of C. Now if I'm solving, I divide by 15, okay? And so I'd say sine of angle C is equal to 12 sine 94 all over 15. And now how do we get C by itself? Well, the way we undo that is we take our inverse sign. Do the same here, inverse sign. Okay, and so I find out that C is the inverse sine of 12 sine of 94 divided by 15. And I find out that C is going to be approximately, round to the nearest degree, 53 degrees. Okay, so I go up here, that right there is 53 degrees. And so then I can find angle B pretty quick. Okay, remember I would do 180 minus 53 minus 94. I do that on my calculator. And I find out that angle B is then 33 degrees. And so I'll use that information, that that's 33 degrees, to find the missing side of B. And so I'd say sine of 94 over 15 is equal to sine of 33 over b. Cross multiply, and I'd say b sine of 94 is equal to 15 sine of 33. Divide by sine 94. And I'd say b is equal to 8.2. Very good. Alright, so we can also look at letter B right here. Letter B says side A is 9, side B is 11, and side A is 61 degrees. Okay, well, we'll see that angle A right here, 61 degrees, is across from side A being 9. It's kind of goofy because this one's side 11 as well. So we think back to what sine actually is. Remember, sine of an angle is equal to the opposite side. So we'll say that opposite side is h over the hypotenuse, which is 11. So to figure out what h is, I multiply both sides by 11. And I say h is equal to 11 sine of 61 degrees. So that means that h, I do it on my calculator, h is 9.6. And so you'll see that this outside number right here, 9.6, is actually bigger than 9. So this is not possible. So not possible.